Hi, everybody. Whether you're teaching online or in a hybrid classroom or maybe in a flipped setting, I think what you're going to see today is going to be very exciting for you. Hi, I'm Dr. J.P. Keener, and I'm the former state director for STEM and a consultant for PASCO Scientific. And I'm going to share you some exciting things that you may have never even thought possible before. I've got 30 years in education. 15 of those were in online instruction. And I already know from my years in online instruction that teaching online is difficult. In fact, if you're trying to learn about Newton's laws or maybe even consider learning about a buffering system, doing that through writing a paper or just reading about it online is next to impossible. You and I both want the same thing. We want our students to be learning with hands-on opportunities, to look at data, to analyze that data, and to share those results back with you. And I'm going to show you exactly how that's done. I'm very excited about today because, first of all, it's Teacher Appreciation Week. So I want to let you guys know how much I appreciate all of our fellow educators out there. And as an appreciation gift, everything that I'm going to talk about today is free. That's right. The stuff that I talk about, the software, the videos, the materials that are online are all free. And of course, today is live. And you probably noticed that from our opening screen. We already had our first typo. We'll go back and fix that in the future, but it's live. Expect that there's going to be some hang-ups, but we've got a lot of great people working today to make this presentation possible. Joining me and working the camera at a socially acceptable distant location is our training specialist, Glenn Starkey, who's going to be running our cameras way, way, way off at a distance greater than 6 feet is our marketing specialist, Janet Gomez, and she'll be taking your questions today. If you've got questions for me, all you have to do is let Janet know in the chat box and just say, hey, JP, I've got a question for you. And Janet will flag me down and we'll stop and we'll discuss and answer those questions for you. But I'm not the only one who's available to answer your questions. We have other experts who are standing by ready to address your questions. If you've got questions about physics, Dan Burns, our physics expert, is waiting to answer those questions for you. Put them in the chat box. Just say, hey, I've got a question about physics, and Dan is going to answer those for you. You've got questions about chemistry. Our own Dr. Sayuki is going to be standing by and answering those questions for you. Just say, hey, question about chemistry. Caroline, can you help me? She sure can. And don't think we've neglected biology. Biology, we can answer your questions too. Barbara Puglisi is waiting to answer those questions. She's standing by at home, ready to answer those questions. And if you've got a dog at home, just like we have a dog here in our studio, Boomer the Wonder Dog, our own PASCO mascot, is here to answer your dog questions about dogs who might be watching our video. But enough of that. Let's get down into the meat of our presentation. I know coming up in just a couple of weeks, everybody's going to get into teaching mechanics. And when you teach mechanics, you're going to want to use a device that you can show your students some very interesting things about force and motion. I'm going to be using our smart cart. Now, I'm happy to say that the smart cart was just pronounced winner for the 2020 NSTA Awards Best in Show. I'm going to show you how I can use this smart cart in 3 easy steps. And let me emphasize those steps to you because we're going to see them over and over again. In step 1, I'm going to collect this data live, and I'm going to show this data to my students. In step 2, I'm going to share that same exact data with my students, and they're going to be able to do analysis. And in step 3, those students are going to do work. It's 3 easy steps, and we'll be doing that with our student. Let's take a look over at Hunter and see how Hunter is doing. Hunter is prepared to learn as we do this, and he's going to show us those same 3 steps. What are they, Hunter? There's step 1. I'm going to get that data prepared, doing it live and share it with you. Step 2, I'm going to share that data file with my student. And in step 3, the student is then going to collaborate however they choose, and they're going to share that data right back with me. 3 easy steps, the same as you do in your classroom. I'm going to show you how easy it is right here. So mechanics, I'm going to be using our smart cart. If you've never seen this device, it's able to measure force with a force sensor, and it's able to measure both velocity and acceleration. I'm going to flip over to our software. I'm going to show you a very nice demonstration that I would be showing to my students online, as though I were doing this online, presenting this online. I've got this hooked up. I've got position versus time. I'm talking to my students. I'm going to start my data collection. And here you can see that I am moving my cart back and forth and simultaneously discussing motion with my students and talking about position versus time with my students. So this is part of the demonstration. I'm live, Hunter is watching me live, I'm doing this demonstration live, and I'm showing that data as part of my lesson. But I want to take this a step further. I want to get into Newton's second law. So I'm going to start a new experiment. I'm going to get rid of that data. And let me make this a little bit bigger for you so that you can see that. And I'm going to collect the force and I'm going to collect the acceleration. And I'm going to drop these onto a nice new graph here. Let me put a nice graph where I'm going to put force on the x-axis and I'm going to put acceleration, or on the y-axis rather, and I'm going to put acceleration on the x. Now, for those of you at home, you know I'm teaching Newton's second law. This is F equals ma. And if I'm able to collect this data correctly, I should see a nice linear relationship between force and acceleration. Let me start this. My students are watching at home. I'm moving my cart back and forth. Look at this beautiful linear relationship. I'm talking to my students about that linear relationship, and I stop. And this is the point at which you're stopping with your students because you want them to do the analysis. And that's great because I'd now be able to share this data file, the exact file that I collected with my students, and I'm ready for them to do the analysis. But while my students aren't watching currently, let me show you something very interesting. Here on my software, I can drop a line right onto this data and get its slope, which is what I'm hoping my students are able to figure out. And if I do that, I can see from my slope here that I get 0.249 as the slope. That's the mass of the cart. And the mass of this actual cart is 250 grams. So through a very easy demonstration, I can do that. But I'm not sharing this with my student. Let me get rid of the analysis. I'm only sharing the data. So step one, I did it live. Step two, I'm sharing the data. I posted it online and I gave it to the students. And in step three, I'm waiting for my results. And the question I posed to my students, what is the mass of the cart? Hunter's got my video. Hunter's got the data. Now I'm waiting for Hunter to do step three, the analysis. So let's pass it over to Hunter and see.
Since force equals mass times acceleration, mass equals the change in force divided by the change in acceleration. That is the slope shown here. Therefore, the weight of the cart is 252 grams. Thanks, Mom.
Excellent. So very nice to have our home set with our own mother bringing treats. Very nicely done. Hunter, thank you for sharing those results. And you can see how very easy that was in 3 steps. Now, suppose you didn't want to do it live. Maybe you didn't want to record it because it could be done easily through Zoom or any type of a web application. You could share this and record it, but maybe you just want to post the link. No problem. If you go to our resources website, right on our main page, actually, if you go to our resources website, you're going to find a variety of videos already posted for you that have these data sets available. And not just the videos, but as you can see from this example, we've got the videos posted with the data sets, and we even have student questions ready to hand off to the students. How much? It's free. All you need to go is go to our website, open up the links, take a look at what you want, post it on your own LMS, send it out to your students, and you're able to teach physics. But it's not just physics you can teach. You might also like to teach a little bit about chemistry. So let me set up a quick and easy little chemistry demonstration you might like to do with your students. I'm going to be doing a titration. And in this titration, I'm going to be using our pH sensor. This is the PASCO Scientific pH sensor. A very nice pH sensor that allows me to measure pH wirelessly. It has a very nice protected bulb on the end so that it doesn't break with our students, and it is wireless. So it's connected directly to my computer and I'm able to share those results. I'm going to do this titration, and like I said before, I can do this through a Zoom platform or a net meeting, doing the titration and doing this titration for my students. Or if you choose, we also have these available for you online. Again, at that resources homepage, we've got these recorded for you. You can take a look at Caroline is doing this, in this case with Roger Palmer, doing a nice titration, showing the results, but not doing the analysis because we want our students to do the analysis. So that's available to you. But in this case, I want to pretend like we're doing this. Well, not pretend. It actually is live. I want to do this live. I'm going to be collecting this data. I'm sharing it live with our student, and he's watching me. He's taking notes, and he's getting ready to do the analysis. I've posted the questions online. I took them right off the PASCO website. I've posted them online, and Hunter is now ready to take it from here. So my step one is in progress. I'm live talking to my students. Now let's see what our students are doing. Hunter.
During step 2, I can see Dr. Keener doing the titration on the screen. I have the data in front of me, and I have the questions he wants me to answer. He wants me to find the equivalence point. So I can use this and work with my friends collaboratively over the internet. Then I can turn my results in through the document where I put my graph, and then I can share it with Dr. Keener in order for him to revise my work.
Awesome. Thank you, Hunter. That was a very nice thing to do. We were able to do that experiment, and you can see now I'm taking a look in step 3. He has submitted his work to me, and I'm taking a look at that. All he did was take a screenshot of his analysis with the graph. He typed up a nice little thing, explained to me how he determined the equivalence point and what that means. He submitted that to me just as he would have done in class, electronically available. So now I did a really nice chemistry lesson, and I did that in a way that now in this type of flipped or rather hybrid classroom, Hunter comes into class, I've got my titration set up, and he's able to move on to part 2. Now, we've talked a lot about using software that I have, that Hunter has, that we have, and I want to take a moment and just talk about that software for a second, because PASCO has 2 different softwares that are available to you. We've got Capstone and we have Sparkvue, and they're both available for your looking at your trial usage on our pasco.com website. If you just type in either Sparkvue or Capstone, you'll be able to find them. But we have those 2. Now, Capstone is a very robust program, and it tends to be the favorite program of our advanced physics and college physics professors because it teaches at such a high level. It gives analytical tools at such a high level. Sparkvue is not nearly as robust. However, Sparkvue can be used on any device, including your phone, whether it be iPhone or Android, your iPad, your Chromebooks, or any device that's available, you're able to use that. And you can download it today from the website. The really nice thing about Sparkvue and Capstone, should you download it, is that it's available to you not just for a little bit of time, but it's available for 180 days. That's 180 days. So if your students are using it today and you're doing this experiment today, they can work with you for 180 days at no cost to the student. They're able to download that today and use it quickly and easily and share that with you over that period of time. The other wonderful thing about this software, aside from the fact that it can run on any device, is that it just won the Presidential Award for Product of Excellence. And you're going to understand why when you open it and use it. It's available to you. And if you don't know which one you want to use, maybe you're thinking I want to use Sparkvue, or maybe I want to use Capstone, which one? Go to the website. We have a nice page that explains to you very easily the differences between the 2 software. And don't panic. If you get started with Sparkvue and decide that eventually you want to move up to Capstone, you can transition the data you collected in Sparkvue right up to Capstone. And we can show you how. It's in our video library, and we're ready to help you with that. So check out our software, 180-day free trial usage, or if your campus or school has already bought a site license, there are no restrictions on the amount of students you can share it with. Share it to an infinite number of students. They can use it for an infinite amount of time. You can do these experiments across your semesters or for the entire year and never be interrupted by the trial usage. But even over 180 days, there should be no interruption. Try it. I think you're going to like it. And if you want to play with any of this stuff today, download it on your phone. Go to your app store, download it, try it. You're going to like it. Now, I've done physics and I've done chemistry. Let me show you something really neat with biology. I'm going to use a very easy setup that's going to use this lamp and our CO2 sensor. Here you can see the CO2 sensor is put into a little bottle. The bottle has some leaves in it. I'm going to put that under my lamp and I'm going to do the experiment. And in this case, I want to take a look at the light and dark reactions. I want to see how the carbon dioxide levels in this bottle change over time when the light is on versus when the light is off. Now, I would love for my students to experience this. And in this case, I'm not even going to do it live. Instead, I went right to the PASCO website. I found the video. In this case, it's Barbara and Roger doing this exact same experiment with the exact same data that they're going to share. So I'm not doing it live. I'm posting the video. I'm putting it online and I'm posting the video with the assignment that I took right off the website, and I'm handing that to my students and I'm letting them take it from there. Step one was easy. I posted it online. Let's see where it goes from there. Let's check in with our students for step number 2.
In step 1, Dr. Keener shared a video with me of the lab. Using this lab, I can see the collection of data. Then in step 2, I can use that data to then continue my analysis. Then when I've constructed my analysis, I can share with friends, we can collaborate, share answers, and then develop our answers with each other. And then we can send that over to Dr. Keener for revision.
Excellent. Could you ask for any better way to be doing these activities in your classroom? Now, if you have questions for us, we're still waiting to hear from you, so feel free to put those questions in. I know Dan is there, Caroline is answering, Barbara is busy taking your questions, and I'm here to answer them as well. Just send them over to Janet and we can answer your questions, because all we're showing you here are 3 easy steps. It's as easy as 1, 2, 3. Let me repeat them for you. Step number 1, do it live or use one of our recordings. Step number 2, take the data that's available that you either recorded or we provided. Send that to your students. Let them have the software. It is free. And step number 3, let them do the analysis and send those results back to you in whatever form you choose. They can export into Excel, upload it into Google, or put it into a Word format and send it to you as a laboratory. It doesn't matter how you choose. In step number 3, you do the results and you give the evaluation. 3 easy steps, 3 easy ways to use these products and this software to teach both online or in a flipped classroom or in a hybrid. Now, I just want you to know that we have this lab available to you, the one that we talked about in biology. It's uploaded for you. It's ready today. Take a look at it. If you've not seen this lab done before, even as a demo, I think you'll enjoy it. But you're going to find the video, you're going to find the data file, and you're going to find the questions available for your students, the ones that Hunter was just answering. But also, when you watch this video, if it's not live or at any time you have questions, I want you to know that we've got resources available for you. If you've got physics questions, I want you to ask them, and Dan Burns wants to hear from you. And if you've got questions about anything in chemistry, Caroline is waiting. Just drop her an email so she can answer them for you. Barbara wants to hear all about your biology questions. And Heidi Brennan, though she didn't join us for this presentation, is waiting to hear about your computational thinking questions. The reason she's not here for this presentation is because she's got her own coming up in just a couple of days. And you can register online. It's computational thinking with Sparkvue or with Capstone. And in that computational thinking, we're going to be introducing a brand new product that has not yet been seen on the market, is only available we're just delivering it starting in the next couple of days, and it's called the Code Node. And the Code Node is an opportunity for us to learn how to code and then show how we can code to learn science. And Heidi's going to talk all about that in her presentation on the 13th. So sign up for Heidi's 13th presentation and win yourself a Code Node. It's a great opportunity. Now, ladies and gentlemen, everything I talked about today is free. You just go to our website and it's available. Those 3 easy steps are available to you with the stuff that we've got, but certainly we want you to support PASCO as we've supported you for the past 55 years. You want this equipment for your classroom, and we want you to have it also. You're going to be able to drop your sales questions to our own sales manager, Isaac Martin, and he's waiting. Just drop a note to Isaac Martin, and he'll be happy to take care of those sales for you. We have a question. Janet.
JP, Sesha's asking if the data play button capstone file is a clean file with no errors, How can instructors introduce some error data points for students to calculate the error analysis or percentage of difference?
Oh, absolutely. That's a great question. And really, the answer to that is our data is relatively clean because we want our students to see some pretty simple data. You can take your own data, and using Capstone, you can measure your own data, put in some data points that are a little off, and help you do the analysis. Our data is clean, but if you want to introduce some really dirty data, you can do that too. You'll find that Capstone allows you, both actually, Capstone and Sparkvue allow you to put in some data that doesn't look necessarily as clean as ours does, and lets your students then see that there's a lot more introduced error. But if you even think back to the smart cart experiment we did at the beginning, and you saw that that was not necessarily a straight line, your students can calculate the standard deviation, and they can take a look at the difference between the different plots, just how we came up with that average in the line. So lots of great stuff there that you're able to do in both Capstone and Sparkvue and address some dirty data. Do you have any other questions? If you do, have them come on in. Remember, we've got those resources, and I really hope that we were able to help you. I'm glad that I got to join you during Teacher Appreciation Week. And how about Hunter and his mom? Were they happy to join you too?
Thank you.
So Hunter and his mom were joining us, and they're going to continue doing their work. I'm done joining you. I'm going to continue doing our work. But for all of us here at PASCO Scientific, we want to thank you for joining us and think a lot about steps 1, 2, and 3 for teaching science. No matter what your modality, we're here to help, and we really are looking forward to hearing about your successes. Good luck and good day.